Hey guys, Mr. Bowman here. The learning objective for this video is in green. We are learning to differentiate polynomials with surds or fractional powers. So, circled the word polynomial, so we're continuing to focus on differentiation with functions of x, so x squared, x cubed, x to a certain power. But this video is going to focus on surds with the power, polynomials with the power as a fraction, so x to the power of 1/2. Or maybe the cube root of x to the power of 4. So there are two areas of focus for this video. So I'm just going to clear that. That's gone. So let's start off with a simple equation. So y is equal to the square root of x. How would we differentiate this equation? So the first step I would always be looking to do, I would always be looking to convert that to the fraction form. So just a reminder, there's a little 2 sitting there, and that x by itself is x to the power of 1. So the 2 goes to the bottom, the 1 goes to the top. So that's our y dash. And we're just going to write down our formula, just to remind us. So y dash is equal to n times a times x to the power of n minus 1. So that hasn't changed, but how we apply it with fractions just requires a little extra effort. So y dash, n in our case is 1/2. A is going to be 1. And then that's going to be multiplied by 1/2 minus 1. So that means y dash is going to be equal to 1/2 of x to the power of negative 1/2. And from here, we typically look to simplify the negative fractional power. So that's going to move down to the bottom of our equation. So 1 divided by 2x to the power of 1/2. And 1 to the power of 1/2, we're going to finish that up the square root of x. And what we've done is we've simplified that equation there. Okay, let's change pen color. Let's get into another scenario. So let's do maybe our function of x is equal to 2x to the power of 3/4 plus the cube root of x. So it looks a bit tricky, very complicated, but let's make sure we're focusing on applying the formula that we're given. So first step, we've got a surd. Let's convert that to a fraction. So the 3's at the bottom, and there's an invisible 1 that will go to the top of the fraction. So the first one's not changing. 2x to the power of 3/4 plus x to the power of 1/3. So we've simplified that. We've now got a fractional power. Let's look to differentiate using our equation. So a times n, well, that's going to be 2 times 3/4, and that will be multiplied by x, 3/4 minus 1. We're then going to add and then differentiate the second part. So that's going to be 1 times 1/3, so that'll just be 1/3 times x of 1/3 minus 1. So let's look to simplify all this to make our life a bit easier. So the first one, 2 times 3/4, that's going to become 6/4, which then becomes 3/2, times x, 3/4 minus 1, that's going to give us negative 1/4. So straight away we've got a negative 1/4, so we're going to move that to the bottom, and we'll need to change it to its surd version as well. After that, we're then going to add 1/3 times x, and that's going to be 1/3 minus 1, which will give us negative 2/3. Let's look to simplify. So the negative power is going to go to the bottom now. So 3 divided by 2x to the power of 1/4 plus 1 divided by 3 times x to the power of 2/3. We then look to convert those to surd form. So don't forget the bottom number sits within the square root sign. So this is going to be 3 times 2, the 4th root of x. And don't forget that hidden 1 is by the x, but we ignore that as well. So plus, we're then going to do the same thing here. So 3 times, so the 3 at the bottom of the 2/3 fraction, that's going to sit in the square root sign. And then x, and we're going to put a squared there that relates to the 2 in the numerator of a fraction. And just like that, we've differentiated our second equation. So hopefully we can see some common themes coming through here. The key step is, if you get to this part here, you'd probably be right in your test, having negative powers. But what I like to do is I like to go through the extra step and simplify as well. So let's do one last equation just to wrap up. We'll switch to the orange pen. We'll make it a simple one. So y is equal to the third root of x to the power of 5. So first step, change it to powers. So the 3 will be on the denominator. So that's going to be x is equal to 5 over 3. And we're then going to look to differentiate. So let's use dy dx this time actually. Dy dx. And it's going to become a times n. So that's going to be 5 over 3 because we have a constant of 1, a coefficient of 1 out front. We're going to multiply that by x to the power of 5 over 3 minus 1. So 5 over 3 times x, and 5 over 3 minus 1 is going to become 2 over 3. And this time here we've got a positive power, so it's going to stay on the top, but that's going to become 5. We still want to convert it to surd form, so that's going to become the cube root of x squared divided by 3. So hopefully you found these 3 examples on differentiating surds or fractional powers useful. The key thing is you do need strong algebra. You do need to be able to switch back and forth between fractional powers and surds to help your differentiation process. And I've gone the extra step. Every question I've converted back to surd form. That's just my personal preference. You may be looking to leave it in fractional forms that we did in the line above. So hopefully you found this video useful. Let's get into heaps of questions.